Is there a way I could get that algorithm?
Get the algorithm for Falcoins.
Yeah. Just start mining on myself too.
I can get you. So you want to mine on the Falcon? You want to start mining Falcoins? Yeah. I can get you onto that.
All right.
You won't hurt anything. You won't get any.
It's just gonna go to your file.
Well, no. I mean, what kind of mining speed would you be?
Oh wow, yeah. I'll probably be doing CPU.
Yeah. So I have 1.1. Well, no, not 1.1. I have 600 gigahashes thrown at Falcoins.
I'll probably get like 4.
And you're gonna be dealing with 75 kilohashes.
It's just gonna get really lucky.
You're like Andre the Giant versus an ant.
Be a good example of
Here's how much electricity I've used. Oh, interesting update point. I don't know if you saw this. I put it on Facebook. CEX dropped their maintenance fee almost in half. They dropped it from 16 cents. Was it 16 or 18 before? 18 cents to a little over 10 cents. It was like 0.109 or something. So about 11 cents per gigahash. So kind of an interesting. I wonder what their motivation was. Maybe it's like, well, the price of gigahashes are basically free right now so on CEX. So maybe they want to get a buying splurge going. Who knows? Okay. So last time we were checking out Coinbase's. Let me. Coinbase's API, and we were starting to look at it from a simple perspective. And we started looking at GET versus POST request. What's the difference between a GET request and a POST request?
GET request puts everything in the URL.
Okay, GET puts everything in the URL. POST passes it behind the scenes somehow as part of the actual POST request package. All right, and our result here, this is just pulling the exchange rates from Coinbase, just giving ourselves an example to start working with, and we'll eventually move over to POST requests with authentication. But we want to look at how do we work with JSON first. So here's Coinbase, and they have an API, and this is one of their API methods, which is exchange rates, exchange_rates. And when you go to this, it gives you a whole wall of JSON, which has all the different exchange rates that they support. Make sense? Okay, and this is in a format called JSON. Why JSON? What's the advantage of JSON? Somebody invented this. Go ahead.
It's a standardized data representation.
Okay, why do we need data representations in the first place?
So that C data as not just stuff.
C data is not just stuff. Why do we need standardized data representations? We need data representations to organize data in some way, right? So we can just divide everything up by commas or divide everything up by colons or something like that. We can have our own proprietary data organization, data representation. But why do we like standards? What's the advantage of a standard?
You can pass the data between people then.
Okay. Why is it easier to pass it between people?
Because they're both working off by people I mean different applications.
Okay.
Because they both are using both are expecting the same format.
Okay. So there can be a standard set of tools in the middle for working with a specific data format, correct? So as an example, .doc. If there's any file that's a .doc or .docx, that's a Microsoft Word file, right? Do other applications other than Microsoft Word open that? Because they support that standard. They understand what the format looks like, and they can therefore read it and then render it. Okay? So having a set of generic tools or standard tools in the middle for working with a standard format is beneficial. And we talked about two different standardization data representation techniques last time. That was XML, which kind of looks like HTML, and JSON. Why has JSON become more popular? Go ahead.
Because it looks like code, so people can. It looks better to programmers, and it supports arrays.
Okay. Yeah, those are actually good points. Go ahead.
It's lighter.
Lighter than.
XML.
Okay. Why? What do you mean by lighter?
You have less characters to represent the same data.
Okay. So XML has all this fluff in it, right? A whole bunch of closing tags, which are reasonably meaningless, and opening tags, which are only a little bit meaningful, and all this stuff. So JSON's lighter, less just fluff. Supports arrays, which XML does not, and it looks more like programming code. And who uses data representation languages? Typically programmers, right? So if it looks nicer to programmers, even though this looks like a bunch of garbage, really what we're looking at here is an opening curly brace followed by a whole bunch of variable names, followed by a colon, followed by a value, followed by a comma. So variable value pairs delineated by commas. That's simple JSON. If we just wanted to give a list of variable value pairs, so for instance, we have VND to US dollars 4.7 to the times 10 to the fifth, ARS to BTC 0.00279, so on and so forth. So we just have a whole bunch of variable value pairs in here separated by a comma, and in the front, we have an opening curly brace. We just have a big wall of these. All right, now there is an older format called CSV, comma separated values. Where did that come from? If you have like an Excel document, a lot of times you can export it as CSV or import a CSV file. So it's a way of organizing data. What's the problem with just randomly delineating data by commas? Why wasn't this just in one gigantic comma delimited list? Go ahead.
You can't tell us the names and what's the variables.
Can't tell what the names and what the variables are. Well, I guess there's some truth to that. In this case, we have multiple delimiters. We have the colon that separates the variables and the values, and then we have commas that separate the variable value pairs. But let's just say these were all just first names. What's the weakness of, I guess maybe first names is a bad example in this case. Let's just say it's a bunch of sentences. Okay? And what's the weakness of having a whole bunch of sentences divided by commas?
What if there's a comma in your sentence?
What if there's a comma in the sentence? How do we handle that?
Change it to something else.
Change it to, instead of a comma, have a different delimiter rather. So maybe it's a smiley face with two equal signs on either side.
Oh yeah.
Chances are nobody's going to have that in their sentence. Let's hope.
$signs.
$signs. Okay, so we can have all these different proprietary formats, right? How is JSON, if you had to generically describe simple JSON, so I'm leaving the array side of JSON out. So we're looking at I'm calling this simple JSON. This is a simple JSON file. How is JSON organized? Specifically, if we're having to write a parser to walk through JSON rather than just look for commas, because commas could be in our values, how is JSON actually organized? We always start with an opening curly brace, right? Then, at the very beginning, then we might have white space. Doesn't matter if we have 4,000 spaces in here or not. And then at the beginning of a variable name, we always have a double quote. At the ending of a variable name, we always have a double quote. After a variable name, we have white space followed by a colon. Then we have double quote, value, double quote. Can we have double quotes as part of our value or our variable name in JSON? You don't think so? Could we handle it? Could we write a generic parser? Could we generically walk through this, playing the role of a dumb computer, and tell the difference between the double quote that closes the variable name and a double quote that might be in the middle of a variable name?
You can have like a backslash prior to the to a double quote that you want to be in the variable name.
Well, we get back to our comma delimited list of sentences. It's just as likely of having double quotes in a sentence if you're quoting something as it is to have a comma, right? Are we going to rely on normal users to put backslashes in there? Probably not. Who uses JSON? So programmers are parsing it. Who's generating the JSON? What kind of entity? What kind of person? Is it Bob the desk worker?
Oh, this is probably a computer feeding out things.
Okay, well, who told the computer how to feed it out?
Bob,
Really? Bob the desk worker is a skilled programmer?
who's also like a really great programmer.
Okay. Probably somebody who understands programming stuff, right? So really, when we think about JSON, we're talking about a communication, a data representation language between two programmers. So is it okay to have representation have some limits as long as there's a standard? Yeah, absolutely. As long as everybody follows the same rules. Now, when we write our simple parser, we're not going to worry about that there might be double quotes in there and stuff like that. I think you would find it very, very, very rare when we deal with variable value pairs for there to be a double quote somewhere in either the variable or the value. Very rare occurrence. So we're not gonna include that in our little implementation. Okay? So really, if we were talking about the generic form of JSON, this is opening curly brace, followed by double quote, followed by var name, followed by double quote, followed by colon, followed by double quote, followed by var value, followed by double quote, followed by a comma, repeat, till you finally have a closing curly brace. So that's simple JSON. We can have as little as 0 values in there. So, for instance, this is a legal JSON document. Open curly brace, closing curly brace. So is one with 300 entries. Like, I don't know how many we have, but we're looking at a fair number in our current situation. Okay? Now, if you remember, at the end of class last time, we were writing the code to actually have a program read from this URL and spit it out to the screen. Right? So we created a URL, put in the exact same thing we put into our web browser, which was a GET request, used a URL connection to open that connection, used our scanner to read from that connection's input stream, and then we just spit the contents out to the screen. We'll go ahead and run that, see we still get our contents. There's our big JSON thing. So we want to manipulate this some so that we get all of our things printed to the screen in a little bit, in a format that's a little bit friendlier for people. Make sense? So we're going to create our own object. And we're going to do it this way first, and then I'll show you how to import a third-party library. So we're going to call this Json Parser. Good enough. So there's our Json Parser. So initially we'll just hold on to the original JSON, but we're going to split it up some. All right. So when we create a JSON parser, we're going to pass in the string of JSON, and it's going to do something with it. Okay. We're going to go ahead and we're going to create just a quick little display method here. It's going to do some of our work. Now initially we'll just have the display method print out the original JSON just to prove that everything's kind of working together. Then we're going to actually do some parsing with it. So we'll create a JSON parser, we'll pass in the JSON string, we'll store it in this global variable, and then when we call the display method, it'll just print it out. That's all that's happening in there. So now we go back out to driver. Instead of printing this out here, we're going to take our JSON string and we'll create an object, JSON parser JP is equal to new JSON parser, passing it our JSON string, and then we'll say jp.display. So it displays the same stuff to the screen. All right, so there's our output, same as before. Now we want to start displaying maybe VND to US dollars equals this, then kick it down the line. ARS to BTC equals this, then kick it down the line, proving that we can extract those values from the JSON. Okay? Now, if we go back and look at our generic representation here, the very first thing that we need to do is we need to peel off the outer layer of curly braces. The opening curly brace and the ending curly brace are unnecessary. It's part of the data representation, but that when we peel that off, now all of a sudden we have a whole bunch of comma delimited stuff, right? In simple JSON, we know the comma delimited stuff will be variable value pairs. In full JSON, we know it'll either be variable value pairs or it'll be another JSON object, which might need parsing. That make sense? Or it could be a JSON array. But we're just dealing with simple JSON where it's literally curly braces with a comma delimited list of variable value pairs. Very programming centric. All right, so the very first thing we need to do is we need to peel off the opening and closing curly braces. And we're going to go ahead and just do this inside of display for right now. All right, so we have a method that is, some of you may have used it before, some of you may not have used it before, but the method is called substring. Belongs to the string class. Substring method takes, there's a couple different versions of it, but one of them takes in an int begin index and an int end index. Okay? And what this will do is it'll give us a substring starting at begin index, including begin index, all the way up to end index, not including end index. So what we really want to do is we want to get rid of bucket 0 and get rid of bucket length minus 1. Or get rid of bucket length minus 1. You get everything in between. Does that make sense? Now we might have spaces beforehand. For instance, is that a legal JSON document? Have some white space before the opening curly brace and some white space after the closing curly brace? Absolutely is. So that's something we need to be careful about, is white space. Because it's not illegal. And actually, when we're transporting stuff over the web, reading it off of a socket connection or, like doing from a web browser, we ignore white space because those are fairly noisy communication channels. When we're establishing a phone call to Google's web server, opening up a socket connection, and we keep reading from that, we might have several reads in a row where we don't get anything because we aren't synced up to this. We can connect that to the organization class. We talk about sampling rate. How often do we read from something? Kind of make sense? All right, so reading in white space, reading in an empty string, or a string that just has some, bunch of spaces in it isn't necessarily uncommon, so we need to account for that. So the very first thing we're going to do is when we get our JSON string, we're going to call a method on it called trim. So we're just adding some tools to your Java programming toolbox. So we have a method called trim. And what trim does is it removes all white space at the beginning and end of the string, not in the middle. So if you pass it a string that had a sentence in it, like "it's really nice outside today," it wouldn't smush all that together into one big blob of text. Only takes the extra characters off the front and the end to guarantee that we're starting with those curly braces. Go ahead.
Is there something that does take all the white spaces out of the middle?
I don't think so. When would you ever want to do that? Just blanketly want to do that? I mean, you could certainly write it. You can write your own method to do it, but can you come up with an example of how that would fit into like a generic tool? Yeah. I mean, it's a good question, but just think about the things that are built into the language are really things that I think you might find useful. So getting the white space off the beginning and end makes sense. Writing the code to just get all white space out of a string would not be difficult to write. I just wonder if there's actually any valid application for that. I can't think of one. Just messing with people. What we do is we send all of your email. Anything that comes in, we send it through our D-white spacer. We also remove carriage returns. Every one of your emails are just one gigantic line of text.
Or, I mean, you could do an encoder thing where you're typing something and it's appearing on the screen as one giant long line of random letters and basically a way to just hide what you're actually typing. So, yeah, and you wouldn't want any spaces maybe because you just want to look like gibberish.
So at a glance, it looks like gibberish, even though a human being could probably read through it and insert the spaces.
No,
I
more
think he was
like,
talking about scrambling the letters.
Oh, literally scrambling the letters too.
Yeah.
Well, so then why even worry about the content? Why don't you just
So that you can't
take however many characters are in your string and just randomly spit characters into a string of equal length?
I don't know. It's just if you didn't take out the spaces, then the words themselves might just be scrambled. I don't know.
I was thinking that from an encoding perspective, you could do just remove all spaces, so you literally have all the right words. They're just all smushed together. A computer would have a lot of difficulty going through and looking for patterns, figuring out how to resplit the words up. But a human being can probably do that on the fly pretty decently. So it might be a quick way of.
Caesar cipher.
Well, Caesar cipher would literally jumble at 13 characters. I'm thinking like something even weaker than Caesar cipher that really is only for human eyes only. Yeah, I don't know. The answer's no. we don't have that one. All right, so when we first read in that JSON string, I'm going to go ahead and trim it right off the bat. So now we're guaranteed that assuming it is a accurate JSON string, we know that the very first character is a curly brace now, and the very last character is a curly brace, because we've taken all the white space off the beginning and end. Now, when we go to display it, or we can call it parse it, whatever, we're just manipulating strings right now. When we go to do that, we want to remove those things. So we're going to use, we're going to say string temp is equal to JSON dot substring 1. So we want it to go from bucket 1 all the way up to JSON dot length -1. This is non-inclusive or exclusive. So it will not get us whatever is that bucket length -1. It will get us everything up to but not including that. This one is inclusive. That'll give us everything from bucket 1 in the string on. That make sense? So if I now do a system.out.println temp, we should see our JSON string with the curly braces removed. No curly braces at the beginning. Just trust me. No curly braces at the end. Here we can. All right, now you're trusting me. There's no curly braces down there. All right. So now what we want to do is we want to print these things out one character at a time. Okay? A couple different ways, not one character at a time, one variable value pair at a time. So we want to split that string, this big long string here, we want to split this guy up on these commas. Okay? Couple different ways we can do that. We can use the string tokenizer to do this if we want. We could use the split method, which also lives in string. Very handy. So there exists a method in string called split. And it takes a string delim as a parameter, and it will split a string up on that delimiter, returning a string array. So returning a collection of strings as a result. So I'm going to go ahead and create my string array. We'll call this guy the parts. And this is going to be equal to temp.split. And what it actually takes is a regular expression, but from our intents and purposes, we're going to have a regular expression that is exactly 1 comma. Make sense? Now, something else we could do up here, just for the sake of maybe cleanness. After we get our substring, we can go ahead and we can trim that to make sure if there was any extra white space inside the opening and closing curly brace, but before your variable started, we'll get rid of those two. So trimming doesn't really hurt. I mean, it's relatively inefficient. We're quickly using this little tool called trim, which just goes and cuts spaces off the end of something. But underneath the hood, it's actually having to do some manipulation and building new strings and stuff like that. But for our intents and purposes, it'll work just fine. All right, so then we get the parts. Now we can go through, we can write a little loop. For int I is equal to 0, I is less than the parts dot length, I plus plus. So we'll go through every single string that lives in this collection of strings, and we'll print each one out. All right, so when we call display, we cut off opening and closing curly braces and trim it. Then we split up the resulting string on commas. Then we spin through that collection of the strings that were the results. We spin through it, printing each one out. And now we should see all of our variables one line at a time.
Now, this is going to be a stupid question, but how is that connected to your last thread of code that actually gave you the website? Like the URL?
Right here, we connected to, well, we created a URL object.
Okay.
We created a connection object that opened to that. Then we read in from that. Well, we created our scanner to read in from that. This is where we actually read in from it. So that line I have highlighted right there will actually be our JSON string. All right? We're passing that to this constructor called Json Parser, which is the guy we wrote. So that's going to come in right here.
Gotcha.
We're going to store it right here in this global variable called JSON. And then down here in display, we're actually using it. Okay? And for those of you who are currently in 250, we're a couple of steps ahead of where you're at, but not drastically. So follow along. You're not going to have to write this on your own. Just kind of try to follow along in such a way that you understand what's going on. Okay, so now we have all the variables printed out, one per line. Now, if we want to split those variables up, we can delimit that on a colon, right? Now, what I'm going to do is I'm going to go ahead is I'm going to create another class here. We'll call this guy a Json var. And vars will have a name, and vars will have a value. The constructor for JSON var will take in a string s. That string s should probably be in the format of variable name, colon, value. And we're going to go ahead and store those values. So s is going to look something like that. Okay, our variable value pair. So we want to split that guy on the colon, like we've done before. So we'll say string, we'll call it the parts again, is equal to s dot split on the colon. So now we know the parts will have two pieces, a bucket 0 and a bucket 1. Bucket 0 will be this part. Bucket 1 will be this part. Make sense? Now, we actually only want to store the variable name and the value, not these extra double quotes. So we want to use that same substring method to get us just this piece and just this piece. So we're going to say this dot name is equal to what? Well, generically you can say it's the parts at bucket 0. But that would have given us this entire string right here. But we only really want the substring of that from bucket 1 to bucket length minus 1. So we're going to do dot substring 1 to the parts at bucket 0 dot length minus 1. So that's our name portion. The value portion will be the same thing, but from bucket 1, the second part of our parts. And then quickly we'll write a little display method. A nice equal sign with an arrow pointing this dot value. So display in a nice format that should be humanly readable. So every single time we create a JSON var, we'll pass in the string in the correct format. We'll split it on the colon. Then we'll set our name and value variables appropriately by taking the substring to cut off the opening and closing double quote from each of those. And then whenever we tell a JSON var to print itself, to display itself, it'll display it in some sort of pretty way for us for right now. So now we can go into our Json parser. And rather than just printing out the parts at bucket I, we're going to create a variable of type JSON var. And then we're going to give it a value in here. We'll say the var is equal to a new JSON var created using the parts at bucket I. So this guy right here will look like that double quote variable name, double quote, colon, double quote, value, colon. And we're going to pass that into the constructor for JSON var. Okay, so this is kind of the same question you asked before. How do these guys connect? This goes into this constructor for JSON var. We pass a string in there. So this string right here comes into this constructor right here as a string.
Yeah, because I was writing that second part and I was coming up with errors like this isn't found.
And then after we create our var, then we can test it by saying the var.display. And now when we run this, we should have a nice, pretty split of all of our variables. Make sense? Now, for us, we're really only interested in US dollar stuff, correct? So what if we wanted to, if we look at that one more time, notice how the stuff is organized? Somewhere it'll have US dollars at the beginning or US dollars at the end as USD. So what we might be interested in is only printing out the ones that have USD somewhere in it. Make sense? So into our JSON var, we're going to build a little search method. And this guy's going to be called contains. It's going to take a string as a parameter. It's going to return true if, actually let's do var name contains. Because we're actually searching the variable names, not the values. So this method should return true if whatever string we pass in here exists somewhere in the name variable. How do we do that? Another little tool. Some of you already know this. Index of. The index of method of the string class. Now, by the way, for those of you who are currently in 250, remember how I said Java is a string-based language? I'm just introducing 4 or 5 other string methods. We notice how powerful these are? I mean, we're manipulating stuff pretty powerfully without us having to do a whole lot of work. I mean, sure, this maybe looks a little bit complex, but you can look at it and see the number of lines isn't drastic. We're doing a lot of stuff in very few lines of code. So the way index of works is this guy returns the index in the string, the first index in the string, where this guy is found, whatever I pass in as that string. Or, most importantly in this case, a -1 if it's not found. So what I can do here is I can say return this dot name dot index of s not equal to -1. So this is going to find out the index of s inside my variable name. If that guy returns something other than -1, for like a 5, so let's say it returns a 5, that means that this string was found somewhere in there. It only returns a -1 if it wasn't found. So this method will return true if it was found and false otherwise. So we just write this little tiny method where we can say, hey, does this variable name contain this value? If it does, go ahead and print it out for me. Just real quick, US dollars was lowercase. So in our parser here, before I display it, I'm going to ask a question. If the var name contains USD, if that's a true statement, then display it for me. So only display the portions that have US dollars somewhere in it. So now we'll have all outputs dealing with US dollars. Make sense? Okay.
What would you want? Only the ones that have US dollars and Bitcoin.
Well, so we can do that too. We can throw another if statement in here. Or actually, we can just do an and. And the var name contains BTC. So if it contains USD and it also contains BTC, then display it. There we have BTC to US dollars, and we have US dollars to BTC. That make sense? Okay, now, when we talk about parsing it, right now we're just displaying this stuff somewhere. We probably want to create a collection of JSON vars so that we can use it again in a little bit. When we get a JSON document, we parse it, split it up. Right now we're proving we can split it up because when we call display, we're actually doing the splitting. We're breaking it into these JSON var objects, and we're displaying those objects conditionally if they meet certain criteria for us. But what happens when this display method's done? All the work we just did is lost. We would have to do the work all over again if we wanted to start over. Now the good news is we did hold on to this JSON string, so we really haven't lost our original data. But to call display again, there's a lot of heavy lifting that's going on in here, right? From our perspective, the code ran pretty quickly. In fact, any delay we noticed was probably the time it took to reach out to Coinbase's website, request that data, and read it from the internet. If we just had that string local, it would take no time whatsoever for it to do this. Perceivable time for human beings. But now the number of instructions would have been high. So there's a lot of crap going on in here. So what we want to do next time is we want to store this somewhere so that we have access to these variables and we can do something with it. All right, now once we do that, then we want to start going over to the authentication side of things now that we know how to work with some JSON. Remind me at the beginning of class next time to pose the question, why did we write our own JSON parser rather than using a pre-built one? It's an interesting question when it comes to Java. All right, I'll see everybody on Friday.